All right, we're going to go ahead and do some problems on lesson 8 problem set. So follow along and make sure you record what you see on the screen onto your problem set. I'll be checking to make sure that you are on task tomorrow. All right, we're going to go ahead and do number 2. Number 2, they want us to rewrite the following addition expression as fractions shown in the example below. All right, so if we're looking at 2a, we got 7/4 plus 7/4 plus 7/4. So technically, that means I am multiplying 7/4 3 times. That would be the multiplication expression right there. Which then we're going to decide, or just think about, if we're doing 7/4 plus 7/4 plus 7/4, what's being added 3 times? Is it going to be the 7 or it's going to be the 4? And hopefully you know that's going to be the 7. So up on top, we're going to go and write 3 times 7 over 4, because our denominators does not add up to 12. We keep them all the same. And so we're going to get 21 over 4 as our improper fraction. And I'm going to have you tell me the mixed number, because how we're going to pull out our wholes. We should be able to pull out 5 wholes, because that's 20/4, 5 wholes with 1/4 left over. All right, let's go ahead and look at 2b. We've got 14 fifths plus 14 fifths. So technically we are multiplying 14 fifths 2 times, which means that the 14s are going to be added twice. So technically we're doing 2 times 14 over 5. And to be able to solve that, we've got 14 plus 14, or 2 times 14 should give us 48 over 5. And I can pull out not only 1 whole, not 2 wholes, not 3 wholes, not 4 wholes, not 5 wholes, not 6 wholes. I can actually pull out 9 wholes. That's 45 fifths is 9 wholes. 45 fifths, 9 wholes. That means I've got 3 fifths left over. And our final one on 2C is 4 sevens plus 4 sevens plus 4 sevens. So I'm going to kind of skip ahead and actually do 4 times 3, because that's what we're adding 3 times, 4 over 7, which then would give us 12 over 7, which means I can pull out at least 1 whole, and I would have 5 sevens left over. So the next one, 3, they want us to do some solving, and they want us to model each problem. And how they want us to model is a fraction of a set, and I'll show you kind of what that means, as well as repeated addition. So we're going to go down to 3a right now, and we're going to model 1/2 times 8. Now that's going to show me with the tape diagram that we're going to do. We're going to take our tape diagram and cut it up into 2 equal parts, 2 units, and those 2 units are going to equal 8. So they want us to figure out, okay, what's 1/2? This is 1/2 right here. What's 1/2 of 8? Well, if we know that there's 2 units in our tape diagram and they both equal 8, well, 1 unit, which is going to be 1/2, is going to be 8 divided by 4, which is, oops, I'm sorry, not 8 divided by 4, 8 divided by 2, which is 4. So that means this is 4 and this is 4. Now the next one is going to be showing the 8 times 1/2 as a repeated addition. So what that means is your tape diagram is going to show 1/2 plus 1/2 plus 1/2 8 times. So we're going to make our tape diagram have 8 equal parts. 1, 2, 3, 4, 5, 6, 7 lines. And technically, each unit is going to be 1/2, which I will be writing 1/2 8 times. So if I have 1/2 plus 1/2 plus 1/2 all the way across, if I did 1/2 times 8, that's going to give me 8 halves. And we know that 8 halves is the same thing as 8 divided by 4. Oops, once again I made a mistake. 8 divided by 2, which equals 4. So the 4 is what's up on top. All right, we're going to go ahead and model 3/5 times 10 as a fraction of a set. So that means that we're going to have the 10 up on the top, and we're going to break up our model into 5 equal pieces. So we just did 5 units equals 10. 1 unit is going to be 10 divided by 5, which that would equal 2. So these are all 2. But we want to find out what 3/5 of 10 is. So I'm looking at these 3 boxes out of 5, which should give me the answer of 6. So very similar problem again. We've got 10 times 3/5. They want us to show it using repeated addition. So what that means is I'm going to have a tape diagram, and I'm going to show 3/5 being added 10 times. So that means I'm going to have 10 equal parts in my tape diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9. And each box is going to be 3/5, 3/5, 3/5, 3/5, 3/5, 3/5, 3/5. I've got this 10 times. So if I added all those up, I've got 3/5 plus 3/5. All of that should equal 30/5, which we should know is 30 divided by 5, which we should know goes in evenly, which is 6. So the whole is 6. So in 4, they want us to solve each problem in 2 different ways. And I'm going to show you the 2 different ways that I would like you to solve, even though the examples, one of them I'm going to show you, the other example we're going to kind of skip and do it a different way. So let's go ahead and look at 14 times 3/7. Now that's like saying 3/7 plus 3/7 plus 3/7 plus 3/7 14 times. And so the 3 is going to be multiplied by the 14 up on top. And the 7 is not going to be multiplied by 14. And so what we need to do here is first multiply and figure out, okay, what is 14 times 3? I'm doing a little side math. Should give me 42. And that's going to be over 7. And so now I've got 42 over 7, 42 over 7, which also means 42 divided by 7. And that's a basic math fact. Hopefully that you know that that's going to give you 6. All right, so now directly across is the same problem again, and I'm going to show you kind of a little trick that we could possibly do inside the problem before we get our final answer of 6. Now we're going to go ahead and kind of start off the same way. We're going to do 14 times 3 is up on top because 3 is going to be added 14 times. The 7 doesn't do anything when you add them. They stay the same. And now what I want you to know is that 7 right now, 7 has a compatible number. 7 can be divided by a number that 14 or 3 also both share. So either 14 is compatible with 7 or 3 is compatible with 7, meaning one of these pairs we can divide by a number that they both share. And I'll give you a hint, 14 and 7 both share a number. Now if I quickly want to show you what number they share over off to the side in blue, I'm going to do my factors for 14, and really quick, 1 times 14 is pretty easy. 2 times 7, and then that's the only 4 factors for 14. And so 7 only has 2 factors, which is 1 times 7, which makes it a prime number. So the number that they both share is 7. So that means we can divide 14 by 7 and 7 divided by 7. So if I do 14 slash, remember that means divided by, 14 divided by 7, the answer that you would get is 2. So we're going to write it up next to the 14. And then I'm going to slash 7, because I'm going to do 7 divided by 7 gives me 1. So if I rewrote the problem with my new numbers, I got 2 times 3 over 1, which is the same thing as 6 over 1, which also means, guys, 6 over 1 means 6 divided by 1. 6 divided by 1 would give me the answer of 6. All right, let's go ahead and do some more practice. Now we're going to take 3/4 times 36. That's the same thing as saying 3 times 36 over 4. And so now what we're going to do is have to do a little bit of a multiplication. We've got 36 times 3 off to the side. Well, 3 times 6 is 18. 3 times 3 is 9, plus 1 more would give you 10. So now we've got 108 over 4. And so now we need to remember that 1 over 8 also means 108 divided by 4. So in green, we got to do a little long division to figure out if 4 can go into 108 evenly. So 4 cannot go into 1, but 4 can go into 10 2 times, because 2 times 4 would give you 8. We would subtract, get a difference, and bring down my 8. And now how many times can 4 go into 28? Well, 4 times 5, I know for sure, is 20. 4 times 6 is 24. So that means 4 times 7 must be 28. And I get no remainder. So that tells me that 108 over 4, which also means 108 divided by 4, is 27. Once again, same problem. We'll get the same answer of 27, but I'm going to show you a little bit of a shortcut that you might want to use when you solve problems on your own, like this. So here we go. We've got the same setup, 3 times 36 over 4. Now we're going to do some cross-canceling. We call these cross-canceling to make some of these numbers become smaller to be easier to solve. Well, 4 can get smaller, and 4 shares a compatible number, or is compatible with 36. They both share a number. Now, if you look at 4, we got 1 times 4, and then we got 2 times 2. Those are the only 4 factors that give you 4. So, just looking at these these 4 factors, 1, 2, 2, 4. The biggest one we have there is 4. So we want to ask ourselves, you know what, if 4 can go into 4, what about 4 can go into 36? Can we multiply 4 by something to get to 36? We absolutely can. That's going to be 9. So 4 is the biggest factor over here next to 4. That means 4 is also a factor of 36. And that's what we're going to use to help make my numbers smaller. So 4 divided by the number they share, they both share 4. So 4 divided by 4 will give you 1. And 36 divided by 4. 36 divided by 4 would give you 9. And so now if I quickly rewrote the problem, 3 times 9 over 1, 3 times 9 over 1 is 27 over 1. And we should also know that 27 over 1 means 27 divided by 1, which gives you 27. So we're going to skip C and go to D really quick and do this one and show you how valuable that cross-canceling trick is. So with this one, we're just going to do normal. We got 9 times 32, and that's over 8. So like I said, we have to do a little bit of some multiplication. 32 times 9, this is where a lot of silly mistakes could happen to get a wrong answer. So you definitely want to be very careful. 9 times 2 will give you 18. And 9 times 3 would give you 27 plus 1 more, 28. So now we've got 28 over 8. So that means 288 over 8. That also means 288 divided by 8. So I'm going to do 288 divided by 8. 8 cannot go into 2, but 8 definitely can go into 28. I wonder how many times. Well, I know that 8 times 3, that's 24. 8 times 4, 24 plus 8 more would be 32. That's too big, so it's going to be 3. So 8 times 3 is 24, and then I'm going to subtract. I'm going to get 8 minus 4 is 4, and bring down the 8. Now, how many times can 8 go into 48? If I can count, I've got 8, 16, 24, 32, 40, 48. So it looks like it can go 1, 2, 3, 4, 5, 6 times. So that's 6. That's 48. Let me erase that really quick. My little. All right. So that's going to give me 6 times 8 is 48 with no remainder. So that means I've got 36 as my answer. All right. So now we're going to do it the shortcut way. A little cross-canceling so that we don't have to do any super duper long division or double digit multiplication. And so here's how we set it up. Now let's ask ourselves, I know 8 has a compatible number with, it can't be 9 because I don't think I could do, let's see really quick the factors for 8. I got 1 times 8, I got 2 times 4. And there's nothing else. So technically, none of these 4 numbers we can use to divide by 9. So 9 and 8 are not compatible, but 8 and 32 are compatible. And so we want to see if 8 can actually go into 32. And if it can, that's what we're going to use. So let's think. 8 times what would give us 32? Well, remember that 8 times 3 is 24. If you add 4 more or 8 more to 24 for 8 times 4, that should give you 32. So 8 and 32 are both going to share the number 8, and we're going to divide each number by 8. So 8 divided by 8 is 1, and 32 divided by 8 is going to give me 4. So now we've got 9 times 4 over 1. 9 times 4 over 1. Hopefully you can quickly understand that 9 times 4 would give me 36, which is 36 over 1, which is technically 36 divided by 1, which is 36. And that's going to go ahead and end the problem set. So whatever we recorded together, or I recorded for you to listen and follow through, I want to see written in your problem set so that I can check to make sure that you're following on directions and staying on task.